I'm just going to pause here. You like functions? Good. Good. I hope you like functions. Okay. Well, chapter 6. So this is Foundations of Math 30, chapter 6, and we're talking about functions. Okay? Functions. All right, so functions. It says on page 377, if you want to turn there, there's a big picture of a roller coaster. Okay? Does anyone know what that shape of that roller coaster is called? A bell curve? Okay, yeah, that's the shape of a bell curve. What about this part? I think I heard it over there. Yeah, this right here, this shape is a parabola. And that is a quadratic function. So y equals x squared. That would be an example of a parabolic function. So again, on your calculators, please stay focused on your calculators. Don't write any messages or play any games in your calculators while we're doing this. Okay, but if you turn them on and you go to this y equals, okay, screen, clear whatever's in there. Clear that off. And I want you to type in x, and then here's the squared button over here. Okay, x squared. Okay, once again, on. Yeah, just get out of there. So escape, hit escape, or clear, whatever it is. Okay. If you're in the probability simulation from last chapter still, just hit the exit button, one of these buttons over here in the end. Just get out of there. Okay, so x squared, that is, again, y equals, that gets to this screen. Here's your x button. That's x, comma t, comma theta, comma n. This is the variable. So if you're inputting a variable into the function there, you hit this button right here. And then here's your squared. If you want to the power of 3 or some other power, that's this button. This is the power button. So you could to the power of 2 as well. That's the same thing. And then you hit this button over here, which is the graph button. Here, Cindy. All right, now, if this shows up, what's happened is someone else has used this for a different class, and they've changed the window setting. So that means that this is zoomed in on a certain part of the x-axis here. So to reset that, we go window, we go zoom 6. Zoom 6, and you should end up with this. Put up your hand if you've got this screen on your calculator right now, looking kind of like this. Okay? Wave frantically if you do not have this. Okay, yes, that is the signal for help. I'm drowning. Okay. So once again, okay. Oh, now you got it. Okay. So we're off. You turn on the on button first. If your screen is blank and you're trying to press buttons, okay, that's not going to work, okay? It's like, yeah, Mr. Maxwell, I have a blank screen. Well, did you turn it on? Oh, no, I didn't do that. Okay, so on. Y equals. Right up here. X is right here. Squared is right here. Graph right here. If your graph is wonky, that's right, I said wonky, hit zoom 6. Then it won't be wonky anymore. That's standard window. Okay? So parabolic. Now, how do I get a parabola to open up the other way or to be upside down from this? Anybody remember? Okay, so if we have the negative version of this, then that's going to work. So a little trick you can do if you want to insert a negative, hit second function. The delete button has an insert right there. So second function, insert, and then hit your negative button, which is down here. Don't press minus if you mean negative. Your calculator will not like you for that, and it'll say error. Okay, so this is minus an operation. This is negative. Okay, now graph it, and there we go, upside down. Okay, so that's an example of a function. That's a parabolic shape function given by a quadratic equation. I know quad means 4, but actually quadratic is x squared. So anything with a squared is a quadratic. Okay? Good so far? All right. A function, okay, if we're talking about a function, that means that we can graph this and the x variable and the y variable. For every x variable, there is only one y variable. That's the definition of a function, actually. You could have other shaped graphs like this. That's okay. That's not a function, because for this x value, let's say there are 1, 2, 3 y values. That's not a function. That's a relation. That's a relation. Okay? So functions, one y value for each x value. And we're going to explore what functions look like and just characteristics of functions. Now, if you're running a business or something and you're trying to graph kind of your revenue or something like that, you may use a function. And then it kind of makes controlling the variables or finding out where your maximum profit is or something like that, it makes that a bit easier. So for example, let's say that this graph represented something like a revenue function. Okay, so this is revenue, and that's how much money you get for running your business. And let's say that this variable over here would be the number of employees. Okay, so the way this would work, this might be a half decent graph to use, some kind of parabolic function. Obviously, this is not just x squared anymore because this is x squared over here at the origin, but this is a form of a quadratic. And what this is saying is that, hey, if you have a certain number of employees anywhere over here, you're going to start to make some money. Okay? Let's say this is one employee making this amount of money. Right? So what happens if you have 2 employees? Well, I guess it would make sense that they're going to be able to be more productive. And you're going to make more things. And you're going to be able to sell more things, so your revenue is going to be a little bit higher than if you had, 1 employee. Does it make sense so far? But the reason why you'd want to maybe do the math is because if you had 1,000,000 employees, okay, would you actually make 1,000,000 times more than you had if you had 1 employee? Well, there are other factors to consider, including the amount of space you need to house, or to have 1,000,000 employees work, all the wages you're going to be paying them, all the benefits, all this stuff. So maybe, just maybe, for your small business, if you employ 4 or 5 people, look what happens. Your revenue actually starts to drop. Now, why would that be? Well, maybe you don't have enough space for all of them to work at once, or they can't, be very productive because of the conditions, or because, they're now formed a union, and so they want to be paid more, so you have to pay them more, so that cuts out of your revenue. Who knows? So this is an example of using math and using a graph to say, hey, it looks like if my math is correct here, if this relation, if this graph does indeed represent, the number of employees I have to my revenue, it looks like if I employ 3 employees, or somewhere thereabouts, then I am going to make the maximum amount of money that I can make with my business. And so that's the way that you can use a simple, a graph to make judgments or to make, decisions. Yeah, this is kind of like the x variable. This is the y. This is revenue, so that's how much money you would make. And this would be the number of employees I had mentioned before. So that's just an example. It's just an example. Okay? All right, so on your calculator, you've already seen, right, what x squared and negative x squared looks like. What about if we had an equation? Now, do this one with me here. Let's say we have x plus 2. X plus 2. Now let's graph that. X plus 2. Everybody graph that. You should have a straight line, first of all, and it should kind of look something like that. Everybody see that? Everybody got that in your calculator? Yes? All right. So this is called a what kind of function? Anyone know? Sorry? Linear function. That is true. This is a linear function. Okay? There are also kinds of functions that, so y equals x, that is a linear function. You want to write this down. Linear function. It's a straight line. Okay? Straight line. And this is useful for all sorts of things. If you have like, height versus time or something, if you're climbing a hill, if you're climbing at a constant rate, it will map out to be a linear function, straight line. We did y equals x squared, okay? That is a parabolic function. Fancy name. Okay, it's also called a quadratic function. Quadratic. And it is a, it's a parabola, so if we're talking about a shape, it's kind of shaped like, a parabola, kind of like this. Okay? It's not a U shape like this. It's not, a cylinder shape. It's not even like this, where these are fairly straight. It's not like that at all. Not this, but it's more of a parabolic shape. You'll get to know them a little bit more as we move through. All right. And then finally we have y equals x cubed. And x cubed is it's a cubic function. That's what it's called. The shape is not all that easy to describe in one word, but we'll graph it. Yep, sorry, question? Okay, so a cubic function would look sort of like this. It would look kind of like this. It would kind of come up to, this part, and then it would kind of like flop on the other side of the line, and it's very symmetrical that way. Okay, that's a cubic function. That's y equals x cubed right there. Okay, and a cubic function is looks like this. Obviously, it has a 3 as the largest exponent. So the degree of the function, is 3. And what's the degree? Well, the degree is the largest exponent on the variable, okay, is the degree. That's what the degree is. And we would say that's the degree of the function. Let's talk about what a polynomial function is. I'm just going to give you some terms here. Polynomial function. Yeah. Polynomial function. Let me see. Where did they describe that? Oh yeah, they described it on the page before. I missed that. So a function that contains only, I'll just read it out first, only the operations of multiplication and addition, or subtraction, really, with real number coefficients, whole number exponents, and 2 variables. Okay, so that's really complicated. Okay, so it's basically one or more terms with a variable and I'm going to put with a variable in brackets. I'll explain that a little bit later. One or more terms added or subtracted. Okay, that's really just a simple kind of bare bones explanation. That explanation in the textbook, I think, is a bit complicated. Now, maybe it's a little bit more accurate, a little bit more all-encompassing, but let me just talk about why I put this sort of description in here. Okay, so one or more terms. So y equals x squared. How many terms is in this? Just look at this half over here. How many terms are there over here? There's one. Now, maybe you're thinking, Mr. Maxwell, this is Foundations 30, and I never really did like algebra, and I don't even know what a term is. That's okay. Let me explain. If I need to back up, just let me know. But a term is basically numbers or variables that are multiplied together in one package. So it's not added or subtracted, it's just multiplied. So this is a single term. That's one single term. If I went like this, whoa, now there are 2 terms there. Do you see how here's one term and there's another term. They're separated by a plus sign.